3D printing is great, of course, and consumer-level 3D printing has come a long ways in recent years. However, it's still a far cry from the home appliance or Star Trek replicator level of technology that many may think it is. We're still limited by the constraints of this type of manufacturing. In order to make the most of it, a designer or engineer needs to employ what we call DFM, or Design for Manufacturability.
Build stuff!
Design for manufacturability means we're going to take into account the method of manufacturing and its limitations before we even start our part design. Here are my top 10 tips to design better, more consistent, stronger 3D printed parts. Number 1, overhangs. You're probably aware to avoid them, but sometimes they are necessary. Here are a couple of tips. First, you can just add a big chamfer underneath the overhangs, because we can print at roughly 45 degrees or less angles just fine, like I did on this recent fan adapter part I designed for a client. You can also split the part into multiple parts and recombine after printing, which is what I did on this Bowden tube inlet adapter for my Voron V0.2 project. This was kind of a two birds, one stone kind of thing, because the part needed to be split in order to be assembled anyways, but you get the idea. Number 2, support material. Just don't do it, or if you have to do it, use it sparingly. Support material is more print time, material usage, and the interface layer will always be kind of ugly and with really inaccurate geometry as it sort of sags against the non-perfect support material surface. Definitely avoid tall supports, especially organic tall supports. They look cool, this like tree-like structure, but they are very much at risk of getting knocked over. As they get tall, they can flex and move out of position and or collide with the tool head as it travels to print the support material. Again, another workaround is to maybe consider splitting the part and then rejoining it after printing. See this example of a part for a Wolverine helmet that somebody sent me. This would require a lot of support material and has no good flat surface to adhere to the build plate. But if I split it into two, then I can get a nice flat surface and I can just glue it back together after it's printed. Avoid tall, thin features. There's very risk of these features flexing as it's printing and or the tool head colliding with it as it travels over to print the next layer. Check out this example from the Save It for Parts channel where our guy had a real heck of a time printing this antenna that had 3 tall, skinny features, and it kept colliding with the tool head and misaligning layers, and he had a ton of failed prints because of this. A much better design for manufacturability would be to split this part up into 3 tall parts and 1 base, so 4 total parts, and then reassemble it after printing. Number 4 is to consider the orientation of your layer lines. This is something most of you are probably already aware of. As the 3D printer lays down molten material, it's adhering to the previous layer, which is already partially or mostly cooled. That means it's significantly less strong across the layer lines than in the in-plane strength. The best case scenario is you're only going to get something like 60 to 70% of the in-plane strength across the layer lines. Again, I'm sure most people are aware of this, but it's something that you can keep in mind when you're designing your parts. An example is this part that I designed for my harmonic drive telescope mount. I initially printed it in the obvious orientation, but it failed across the layer lines. So instead, what I did was split it in half. Now I've got 2 nice flat surfaces to adhere to the build plate. It prints in the much stronger orientation and then glued it back together. Number 5, we'll talk about hole sizes. Holes printed parallel to the print bed surface will generally be round, but you may need to consider the Z-seam, a little bulge of material as the print head stops and starts when it prints each layer. This will make the actual hole size a bit smaller. I usually find holes come out smaller than you design, and usually what I do is if it's a hole that needs to be a specific size a tight tolerance hole, I'll just print it undersize and then drill it out afterwards. For holes printed perpendicular to the build plate, it's a little bit trickier. As the hole is printing, the top of the hole will end up being this overhanging arch shape. Again, you can just drill these out to size for smaller holes. For larger holes, it's a bit more challenging, as the overhangs will be a lot more material. One workaround is to just not design that part of the hole. Instead, design a hole with 45-degree overhangs, because we can print those, and then a flat bridge section, which will print nice. Now, of course, this means the hole won't be perfectly round, but depending on your application, this may be a trick way to print really nice looking shapes without saggy overhangs, and it will function for what you need. Number 6 is counterbore holes for a socket head cap screw printed face down against the build plate. These would normally need support material, which will leave a rather ugly looking hole and it will be very difficult to clean out. Instead, one workaround you can do is to just counterbore the hole a little bit deeper and then add a 45-degree chamfer to the edge. This isn't mechanically ideal, as now the head of the screw is sitting against this chamfered edge instead of a flat edge, but for most of our plastic assemblies, this is going to do just fine. Number 7 is to add fillets or chamfers to the corners of your parts. This is something I see a lot online. Having a sharp angle, like a 90-degree corner, will lead to stress concentrations, and especially on plastic parts that may be prone to cracking, this is going to be a weak spot of your part. Also, having fillets or chamfers against a floor and a wall of the part can increase the surface area and thus layer adhesion. Number 8 is to consider your extrusion width and your layer thickness when designing walls and tops and bottoms. It's a good idea to use even multiples of whatever your extrusion thickness is and your layer height. Tip number 9 is engraved logos or lettering. If engraving against the bottom surface of your part, I like to engrave just one layer deep. And when you print, the bottom layer will print and have a nice outline of your logo. And then the second layer will just lay down unsupported over the engraved logo. And the result is, depending on the material and how much cooling and how big the engraving is, the material will just kind of sag down into that channel left by the engraving. The end result is that print will look pretty good and actually can end up with a smooth surface with a nice outline of your logo. Alternatively, you could make the engraving a little bit larger, then print the logos separately in a different color and glue it in, or use a multi-material printer if you've got something like that. For vertically oriented engraving or logos, you just want to consider how much overhanging material you may have. If it's engraved too deep, you could have really thick overhangs, and that could lead to your logo looking kind of ugly or misshapen. I would stick to pretty thin engraving. And number 10, just a brief discussion about tolerances. Generally, 3D printing, even really high-end industrial 3D printers, are going to be pretty limited in the tolerance specifications the machines are going to be able to hold. This typically will be no greater than plus or minus 10 to 20 thousandths of an inch, or plus or minus 0.1 to 0.2 millimeters. Consider that with FDM 3D printing, we're extruding a thin line of molten, almost fluid-like plastic down onto slightly cooler plastic, onto a build plate that's at a different temperature, and that's inside a volume of air, and something is moving, either the build plate or the print head is moving. There's just a lot of variables going on here, so it's not realistic to expect that we're going to be able to be consistent greater than, a range of 0.1 to 0.2 millimeters or so. Also consider that the part will be cooling and changing its shape as it cools during the printing process. And then, of course, the parts will cool and shrink or expand non-uniformly depending on the geometry of the part. If you've got a really thick section next to a really thin section, those are going to sort of warp and cool differently as the part cools. So we need to take these limitations into account in our designs. If you have a feature that does require a very specific fitment or tight tolerance, then we may need to simply do a second operation after printing, something like drilling a hole or drilling and reaming a hole out to size after the part's been printed. We also can just take this into account in our designs by building in adjustability. So instead of trying to get a specific hole pattern exactly right, we do slots so parts can slide and adjust, and then we use other features to align the parts appropriately in our assembly. Okay, and I got one bonus tip for you, and that is just don't 3D print the part. 3D printing is great, of course, and it's novel to say, oh, my thing is fully 3D printed, but I tend to view 3D printers as just another tool for making things. It's a great tool, but sometimes it's not the best for the application. One example would be large flat sheet parts. Sure, you can 3D print those, but there's much faster and more efficient ways, like CNC routing or laser cutting or water jet cutting, or even just cutting it out by hand. I employ this a lot in the things I design and build. See, for example, the 3D printed bicycle that I built or my telescopes. So that's it. That's my top 10 with one bonus tip for how to design really good 3D printed parts. What did you guys think? Did I cover everything? Is there something I'm missing? Maybe you'd like me to elaborate more on some of these tips. Let me know down in the comments. You also might consider joining the Discord server, which the link is in the description below. Happy to help you out with projects over there and discuss 3D printing, telescope building, whatever kind of maker stuff projects you've got going on. That's a great spot for it. If you'd like to support my work, you consider just sharing or liking the video, but also you may consider joining the channel, or I have a Patreon account also linked down below. Thanks, and I'll see you on the next one.